Hello, Chemistry 10HH student. This is Mrs. Altman. We are on video number 15, Atoms, Molecules, and Ions, Part 2. Here are our objectives for today's video. Pause here. So we talked about ions a little bit last chapter. We're going to be talking about them a whole lot more this chapter. So they are formed by an atom gaining or losing electrons. You cannot gain or lose protons. That would fundamentally change the identity of an atom. And then when we form something that is positively charged, it is called a cation. So that T looks kind of like a plus sign. That helps you remember that. And then anions are formed from the gain of electrons to form something with a negative charge. Pause here. So we've talked about isotopes before. This is just a formal definition. So they are atoms of the same element that have the same number of protons, but they have different numbers of neutrons. The only thing that is affected by that is the mass. The chemical properties are not affected by different isotopes. Pause here. Okay, so I'm just going to get right to it. So it is magnesium, so its atomic number is 12. It's giving us the mass number, and it says it has a charge of +2. And then again, it is magnesium, has 13, so instead of having the mass number of 24, it's going to have the mass number of 25. And there's nothing in here to indicate a charge, so I'm not going to label any sort of charge. Pause here. Right, so we'll talk a little bit about properties of these materials and also where these are on the periodic table. So this you should mostly know. Metals are shiny, they conduct heat and electricity, they're malleable, they're ductile. The reason why this is true is because of the fact that metals often have valence electrons in loosely held S or D subshells. There is some variation to that. We'll talk more about that in class. These loosely held electrons reflect light pretty easily. They also create what's called an electron sea, which makes this material more malleable. It makes metals able to conduct electricity since we have freely moving electrons. If you didn't already know what malleable means, it means it's able to be hammered into thin sheets, and ductile means it can be pulled into wires. And then let's take a look at the periodic table. So for the periodic table, you make sort of a staircase underneath of boron, then underneath of silicon, underneath of arsenic, underneath of tellurium, and underneath of astatine. So the things that are on the staircase, and when I say on the staircase, I mean they have a face on the staircase. So boron, aluminum, silicon, germanium, arsenic, antimony, tellurium, polonium, astatine. These are all what's called metalloids. Except for aluminum. Aluminum is an exception. Aluminum is a metal. Everything that is to the left of the metalloids, including the F block, so everything in the S block, everything in the D block, and these weird ones down here in the P block, as well as the F block, these are all metals. So the vast majority of the periodic table, those are all metals. Everything that is on the staircase, with the exception of aluminum, is a metalloid. And then everything that is to the right of the staircase is a nonmetal. The other exception I expect for you to be familiar with is hydrogen. Hydrogen is actually a nonmetal. Nonmetals, there's a little bit more variety. They don't have specific properties that are associated with them, but they in general don't conduct heat or electricity well. They can be solids, liquids, or gases. They don't tend to conduct heat and electricity very well because their electrons are held in these p orbitals, and those tend to be held tighter. And then metalloids, you have a mixture of the two. So metalloids tend to be what's called semiconductors, which means that they conduct electricity at some temperatures or under certain conditions. Those conditions are typically related to the temperature. So typically at high temperatures, they conduct better than at low temperatures. Great. Thank you so much for watching, and have a great night.